In this recording, we're going to learn how to solve trig equations that have either more than one trig function or more than one angle. This is a very challenging activity because it involves algebra skills, trigonometric skills, and identity substitution. But fortunately, we have some checking techniques using the calculator that will confirm our answers and give us the confidence that we're on the right track. Don't want you to write anything more than the heading right now. If you could just write down the heading, then we can proceed to look at the two equations that we're going to consider and try to solve today. Okay, so I don't need you to write these two equations down yet. We'll get to them later. This would be one of the trig equations. We consider this equation in this category because it has two different trig functions. It has both a cosine and a sine. I'd like you to jot down these steps. Play the recording when you're ready. Okay, so hopefully you paused and wrote down those steps. Okay. So the first equation, I'm actually going to grab this information right here, paste it up in here. We're going to make use of that one. First off, we're going to look at the graph to figure out how many solutions we anticipate having. So let's grab a graphing calculator. If you don't have one, just follow along. We're going to put in first cosine squared theta. So we're going to go cosine. You might say, how am I going to enter squared theta? You're going to go cosine of x, close it off. You got to close it because it's not the angle we're squaring, it's the function. Cosine of x squared, and then we're going to go plus 2 sine x, close it off. And then if I wanted to make it equal 0, I'd have to subtract 1 from both sides, so I think that's what I'll do. I'll subtract 1 from both sides. Now I'm going to go zoom. Well, first of all, I'm going to get in degree mode. I'm in degree mode. Okay, that's good. I'm going to go zoom 7. I would suggest always being in degree mode when you're checking your answers to graphs. It's a whole lot easier to read the solutions when you're in degrees. You can always convert over into radians if need be. All right, so as I'm looking at this, I wanted to be between, let me just check back, 0 and 360 degrees, including 360. So it appears to me that there's a solution here, here, and here. If this were multiple choice, I would jump right in and start looking at the answers. It seems like it's 0, 180, and 360. Okay, so we have in mind what we think the answers are. Let's show the work and get those answers doing the algebra. Okay, so first off, I wrote down a technique here. Try to factor out one function or rewrite the equation in terms of one function. I want to get them all into sines or all into cosines. And I think what I'm going to do is replace this cosine squared theta with something it's equal to. And if you remember from this identity, cosine squared theta is equal to 1 minus the sine squared theta. So I can make that substitution. 1 minus sine squared theta. While I'm at it, I think I'm going to subtract 1 from both sides. If it's okay with you, I'm going to get it equals 0. So there's a quadratic involved. Eventually, I'm going to want it equals 0. So at this point, I'm going to combine the like terms. I see a 1 minus 1. Those are gone. And I've got negative sine squared theta plus 2 sine theta equals 0. I don't really mind the negative there, but it'd be more familiar if it weren't. So I'm going to multiply everything by negative 1. Just to get that leading coefficient positive. We're a little more familiar with that. So that's sine squared theta minus 2 sine squared theta. I'm sorry, minus 2 sine theta equals 0. Okay, let's use our technique with the m's to take it from here. In fact, why don't you take it as far as you can? I'll just be here if you need me. I'll play the recording when you're stuck. Okay, so hopefully you took time to get as far as you could. We're going to turn this into an m. So we're going to go m squared minus 2m equals 0. We're going to use our quadratic formula. So a is 1, b is negative 2, c is not there. Use our discriminant first, b squared minus 4ac. So I'm talking about a negative 2 squared minus 4 times 1 times 0. Well, the times 0 makes that whole thing go away. This is just a 4. Alrighty. So now I get into the rest of the quadratic formula. M equals, we'll call it x equals, but it's really m, negative b, so positive 2, plus or minus square root of 4, all over, let's make that 4 super clear, that kind of looks like a 9, plus or minus square root of 4, still look like a 9, take 3, that's better, all over 2. So when we simplify this, we break this out into the two equations, it's going to be 2 plus or minus 2, so we'll go 2 plus 2 over 2, and then on the bottom, 2 minus 2 over 2. On the top, it's 4 over 2, or 2. On the bottom, it's 0 over 2, or 0. All right, so let's consider what that means, what that implies for us. From the first equation, I'm going to turn that back into sine. Sine theta equals 2. Well, it cannot. There are no solutions to that. If you remember your graph, it only gets as high as 1. If you try to inverse sine a 2, you will not get any solutions. The other option is that sine of theta equals 0. Well, let's think about the normal sine graph and how many places the sine could equal 0. Well, it could happen right here, could happen right here, could happen right here. So I'm thinking about 0, 180 degrees, and 360 degrees are all the places. Now, that sounds familiar. Wasn't that what we said here? 0, 180, and 360? All right, so based on that, I think we have our 3 solutions. That theta is equal to the solution set 0, 180, and 360. Nice.